All right, hi people watching this video. This is Algebra 2, the Chapter 8 review. We're doing some whiteboards today. So yesterday I kind of went through some review stuff with you of the back side of your review. If you still have questions on that, come see me sometime. But I just gave out a sheet that looks like this. You have one of these already, except on the back side it has a couple curves also. You can certainly use that one on your test, but I just gave them a blank one that has nothing on the back side of it, because that one I will allow you to use on your test. And we're going to put these two things on the back, which is margin of error and finding the sample size. Okay, so these are two things that you're going to need to include on the back of your review. I see some of you writing already. That's the right idea. That's the right thing to do. But you can, yeah, if one of them works. So put these on the back side of that bell curve sheet. If you don't have one of these blank ones and want to come get one from me, you sure can. Otherwise, you can use the one that I gave you in class. When I gave that to you, it just has stuff on the back side of it. You can just put these two things wherever you can fit them on that bell curve sheet. That's no problem either. So margin of error, I don't expect you to memorize that. And then finding sample size, like how big the sample has to be. Okay, good. I'll give you a second to write that down. Good. Okay, now my question to you, before we move on to the actual question, why do we have a plus and minus in front of error?
Because it's the margin, so it's minus the mean and plus the mean.
Yes. So you take whatever percentage you're given and you subtract the error, and you add the error to that certain percentage. Okay, here's your first example that has that process that goes in here. Here we go. Here's some information at the top. So we surveyed, you don't have to write this whole thing down, just write out the important stuff, okay? We surveyed 100 kids, and we found that of those 100 kids, 35% of them have broken a bone in their life. I'm just making these numbers up, right? I didn't actually do this. But 100 kids, 35% of them have broken a bone. First thing I want you to do, find the margin of error, okay? So use that margin of error formula to figure out what your margin of error is, okay? Go do that first.
What is N? What is N and what is E?
N is the number in your sample, and E is the error. So we're trying to find error, so we use E, and we plug in some stuff, right?
Would it be?
What is here in just a second?
Got it. So 35 or 100.
100. 100 is your N. Is the number that you use. Yeah.
This marker's full.
You got a calculator? Does that one turn on?
Yeah.
Does it work? Okay. No.
So 100 is
What? Did you get an answer?
plus minus. Yes.
All right, so here's what I got. Okay, that's fine. Here's what I got. Plus minus 1 over the square root of n is the formula. What is n in this case? N is 100. That's the number of people I've surveyed. So 100 here. And then we do times 100. What's the square root of 100?
10.
So this is saying like 1 over 10 times 100. What's 1 over 10 times 100?
10.
Plus minus 10, right? So my error is plus minus 10. And my error is represented as a percentage. So plus minus 10%. Okay? Now, it's not fair for me to say that exactly 35% of all kids have broken bones, right? Because it could be off by some. And we're saying that if my error is 10%, it could be off by 10%. So the next thing I want you to do is find the range for percentage of kids who have broken a bone. If the error is 10%, what range of value should I actually say is the percentage of kids that have broken a bone? 25 to 25% to 45%. So what's more accurate is to say that if I'm going to survey all of the kids everywhere, right, not just the 100 that I've sampled, all of the kids everywhere, it's more accurate for me to say that somewhere between 25 to 45% have broken a bone, right? Because my error is 10%. So I add and subtract the 10% from the 35. That's where that comes from, right? Okay. Now, what happens if I want this range to be smaller? What do I do?
You add more people.
You survey more people. That's exactly right, right? Like I would ask more people. I would ask 200 rather than asking 100. And then that range might be closer to like 35% to 40%, right? That would be more accurate. It would be like a closer range, right? The more people I survey, the more narrow that range gets, okay? So here's my next question. This is going back up to here where it says find the sample size, right? So this is saying how many people do I have to survey if I want my error to be this much, right? In the last example, what error did we calculate? 10%. I'm saying I want less of an error. I want 5% error. How many people do I need to survey if I want 5% error? Now, how many people did I survey last time? 100. Am I going to have to survey more than 100 or less than 100 if I want 5% error? More than 100, right? Okay, do that. N equals 100 minus E, or 100 over E squared. Yeah, now here's the thing that people get confused all the time. They say 5%, and they plug the 5% in here, but they're like, okay, does it go in as 5, or does it go in as 0.05? It goes in just as 5. We don't actually convert it to a decimal first because that's what the 100 is doing, right? The 100 moves the decimal for it, okay? So you do insert it as 5 and not as 0.05, and when you do that, 100 divided by 5 is 20, and 20 squared is 400. So I would have to survey 400 people if I want my error to be 5% rather than 10%. Make sense? The more people you survey, the more accurate you are, which means the less error you have. They're like vice versa,
What you
right?
need is you need a 0% margin of error.
And a 0% margin of error would occur if you surveyed everybody, like the whole population. That's when you would get it. But now, we talked about population versus sample, like way in chapter, like section 1. Population doesn't necessarily mean U.S. population or the world population. I could be focusing my population on just the population of Nebraska. Or I could say just the population of Blue Hill students. I could survey the entire population of Blue Hill students, right? Like it might take a while, especially nowadays when everybody's sick, you know, like.
Yeah, especially when
But I could do that, like that would work, right? I could survey an entire population. It just depends on what my population is,
Yeah,
right?
I'm gonna survey the
So,
fish in the pond.
anyway, okay, next. I have 2 questions that depend on this statement up above here. It says 400 total students in the school. I'm just saying there's 400 total students, okay? Don't get bogged down by the words in here. Find the proportion of track kids if there are 80 kids out for track. What am I asking you to do? Find the proportion. What's a proportion?
Percentage.
Like kind of a percentage, right? You could put the percentage as a percentage or a decimal, right? But how would I figure out what proportion of kids are out for track? What? Divide what?
400 divided by 80 for the other.
I would go 80 over 100. 80 divided by 100. So this says 80 out of 400 students go out for track, and that is 0.2 as a proportion, or you could say 20%, right? Like, those are easy problems, right? Don't get bogged down by all the words, okay? Find the proportion of boys that are in the school if there are 250 boys. 250 out of?
0.65.
Okay, now do some of these calculations kind of in your head, or at least guesstimate what this would be, just so that you make sure your calculator's doing it right. Are we talking about more than half or less than half? More than half. So we know that it's going to be more than 50%, right? What do you get exactly? 0.625? 0.625, or 62.5% of your school would be boys, right? Okay, or 5/8. Yes, exactly right. Okay, so proportion, I'm talking about like decimal or percentage, right? Those should be nice, easy questions. Okay. Next one. Here we go. These are going to be your bell curve questions. They give you an average. We're talking about on a test. The average is 80 on your bell curve. Where does that average go? Middle. Okay. My standard deviation is 5. So we're adding 5, adding 5, adding 5, subtracting 5, subtracting 5, subtracting 5. And then you're dealing with the percentages. So what percent scored above a 90? Do your bell curve. Look at this sheet to figure out what percent that is. Get a percent. Don't shout it out. Let everybody get the percent, and then we'll calculate it. I cannot hear out of this ear right now. I don't know. Don't say it. Don't say it. Wait till everybody gets it. Don't say it. Don't say it. Don't say it. And I gave you really nice numbers. On the test, I might not give you so nice numbers.
I got it.
What's the answer?
Okay. Oh, what percent of students scored above a 90? Above a 90 on the test.
Oh, that.
I'm going to add a question to this.
Oh. Got her.
Okay. Did you get it?
Oh, wait.
Got it? What percent of students scored above a 90? Okay, so if we're looking at standard deviation wise, 0 lives in the middle, right? 0 is your average. And then this would be like +1, +2, +3. Do you remember what we called those? -1, -2, -3. Those were called the... That's how many standard deviations you are above or below the mean. That's called the z-score, yeah. So if you have a z-score of 1, you scored an 85 on the test. If you have a z-score of -3, you scored a 65 on the test. If you have a z-score of 4,
Got 100.
you got 100, right?
I got a Z-score of 5, bro.
You got a z-score of 5, you got 105 on the test. Okay, so they want to know above 90, okay? So we're looking at everything above that 2. Let me go to my bell curve. I'm going to make you dizzy. Everything above 2. 2 is right here. 2 and above is 2.4% plus 0.1%, which is 2.5%. You're adding those percentages together. All right, I'm going to go back down. 2.5% is this guy. Okay, did you read my next question?
I did all 3.
Do that one. What percent scored below an 85? What percent? They're doing what you're doing, Lily. You did this a long time ago, though. Yeah.
84%.
They're doing the empirical rule sheet. Are you waiting for him or what?
Yeah.
Oh.
I'm just fine. We have nothing to do.
Oh, nice. Okay. All right. What percent scored below an 85? Did you answer that question? Below an 85. Below an 85, we're talking about like this guy and on back. Okay, now, you might have taken like this category, this category, this category, this category, this category, and added all 5 of them together. But you can subtract them too. What percent of people are from here back? 50, right? Like this is 50%, right? 50% is all that. How much is in between the 0 and the 1? 34. So 50 and 34 is 84% are going to be the ones that scored below an 85. 84% scored below an 85. Huh. Okay, number 3. What percent scored between a 70 and a 90?
95%.
I got to erase all my stuff here. 70 and a 90. 70 is -2, 90 is +2. Percent between -2 and +2. You actually have that on your sheet. Between -2 and +2. I'm making you dizzy. Sorry. -2 +2? What?
I should hope everybody gets between a 70 and a 90.
I know. But not everybody did. What percent did?
Yeah, Isaac got a 60.
95. Isaac, you've been voted off the island. They said that you're part of the 5% that got below a 70. Whatever.
It was the 2.5.
So 90, but there could be, I mean, maybe we just need to give Isaac some credit and say that Isaac is in the top. He's above the 90%.
Oh, no, he's not.
Right?
No, he's
so he
not.
scored up here. This is where Isaac lives, right?
Oh, no.
We're-
No.
Whatever.
No,
Anyway,
no.
Okay, sorry. Isaac, they don't have very much faith in you. I have faith in you, Isaac. You're going to score above the 90. All right.
That's
So
a big
95%
praise.
of
That's a big
students.
praise.
So that's what this is. 95% of students. He's probably not watching this video right now, so it doesn't really
He's
matter.
never going
Okay.
to.
What
We can
percent of
tell him when he
students
gets back.
scored between a 70 and a 90? Now, I'm going to do the same thing again, but I'm going to give you harder problems. And here we're talking about prices of cars, okay? Prices of cars. So we have a car lot, and these are like gently used, maybe new cars, right? And $25,000 is what our average is for a car with a standard deviation of 6,500. What percent of cars cost less than 5,500?
6,500.
5,500. Yep, 6,500 is my standard deviation. Okay, fill out your bell curve first. That might help a little bit. 6,500 is your standard deviation. 5,500 is the amount. Anything below 5,500. I know. See, I gave you one. I had to give you one that was a little bit harder so that you couldn't do it in your head, right? Less than 5,500. And then I give you a hard one on number 2. What percent of cars cost less than
5,500 instead of 6,500.
Oh, for your standard deviation?
Yeah.
That stinks.
I got it.
There you go. Here's the right numbers.
No, John, stop looking at my answers. 1%. What did you say?
Okay? All right, where is 5,500 located?
Where's what?
At the like the -3 spot, right? What's below that?
0.1.
0.1%. Like not even 1%. 0.1%. That kind of stinks. That is not my car lot if only like less than 1% of the cars are less than $5,500. Could you guys afford cars that are, I mean,
used vehicle.
I don't know.
50% of them are over 25,000.
Right. That's exactly right. Yeah.
That's
It's a lot. It's a lot. 0.1%. All right. Now, here's the kicker. I ask you a little bit different question in this spot, right? Number 2, if my car lot has 50 cars, how many of those cars would cost less than $3,800?
Precise answer is 1.25.
Can we see the thing again?
Mhm.
I don't have
How many of those cars would cost less than, or no, was that less than 3,800?
More.
More than 3,800. How many of those cars cost
Precise
more
answer.
than 3,800?
1.25.
I'm confused.
Yeah.
So the way that your bell curve works, right? 3,800 is at the +2, right? So if I'm looking at my bell curvy thing, right here, okay, 2 is at this spot right here, and 3 is at this spot right here. So 2.4 is the percentage that's in between 2 and 3. Does that make sense? And 0.1% is the percentage that's above that. So this would be 2.4%, and this would be 0.1%. Make sense? So yeah, you would use both of those. Yes. So 2.5% are above. 2.5% of my cars are above 38,000, right?
1.25.
Okay. But if I say my car lot has 50 cars, how many of those? I would take 2.5% times 50. But 2.5% as a decimal
0.025.
is 0.025, right? And I take that times 50, and Gabe says it's 1.25. So how do we round that?
1. 2.
We round it to 1, okay? The only time we round up,
If it's
even though,
1.5.
is when we're talking about margin of error,
Oh, okay.
right? Like if we're surveying students or whatever, and we have a certain margin of error or whatever, like we're trying to figure out how many students we have to survey. Like when we're doing these problems, right? We're trying to figure out what n is. Let's say my margin of error is, I don't know, let's go 7. Let's go 7. 7% margin of error, right? What's 100 divided by 7 squared? This isn't going to come out nicely.
7% squared.
No, it's not 7%. That would be 7 divided by 100.
0.08.
This would be 204.08. So how many students would I have to survey in order to get a 7% error?
205.
Even though this is 0.08, I would have to survey 205. Because if I surveyed only 204, I would end up with a 7.1% error or something like that, right? And I want just 7.
Just come with you.
Yes.
My dad would take that 1.25 deal on that car. He could buy a car and then take the axles off the other car.
I think so.
Deal,
Yeah,
deal,
maybe.
deal.
Okay, all right, next, this one right here. Okay, we came up with some hypothetical numbers, 6th period, and we said that, we're talking about how many TVs you have in your house. How many TVs do you have in your house?
Whoa.
They were like, I gotta count for a
3.
second. You have 3? What do you have?
5.
5? I have 5, but one we don't use.
I know.
Very often.
1, 2,
You have 4?
3, 4,
Oh,
4 with maybe a 5.
With maybe a 5?
Oh, dang it. I got like, please come at you. I think I got like 7.
Holy cow.
We at one point had like.
Okay, So we came up with some hypothetical numbers. We said that 7 students out of a group had 1 TV in their house, and that was it.
They're unlucky kids.
I know. We had 12 students that have 2 TVs. We have 15 students have 3 TVs. 6 students have 4 TVs, and 4 students have 5 TVs. What is the average number of TVs per household? How do you do it?
Add all those numbers up and divide by that number.
Which?
No, you go 7 times 1.
Okay. 7 times 1, sure. Okay. Plus 12 times 2.
Yeah.
Plus 15 times 3. Okay, I'll buy this. Plus 6 times 4. Plus 4 times 5. Okay, and then what do you divide by?
Students.
Do you divide by students or divide by TVs?
Students.
Students? How many students are there?
19.
I think it's 44. Check me though.
22 plus 8 plus 6
Okay, if I add up the number of TVs, that's 15. Do you use 44 or 15 when you divide?
44.
Why do you use 44?
You want to get rid of the students.
You're trying to find TVs. So I have to divide out the students, right? So I'm going to divide by 44. Okay? All right, I'm going to do some math in my head. 7 times 1 is 7. This is 24. This is 45. This is 24. And this is 20. Okay? So adding those numbers together might be a little bit faster. 7 plus 24 plus, I think it was like 120 or something. 120 divided by 44.
2.72.
2.7, I think it's 7.3 if you round, right? So the average is 2.73. Now, we should have guesstimated, we should have guesstimated before we started. About how many do you think?
3. That's 3, right?
Why do you think 3? By looking at the numbers in this table, why do you think 3?
Because most kids have 3.
Most kids have 3, but what's the second highest category?
2.
So I'm going to guess a number between 2 and 3.
It's pretty close.
Probably on the high end of 2, right? Closer to 3 than it is to 2. 2.73, that sounds appropriate, right? Okay?
10, 4, and 5, and all 7.
Right. Yes, correct. 10, 4, and 5, and then only 7 on the other side. Yep. So got to be on the high end of that. Okay, is this the last question? Last question. Make a box and whisker plot.
Oh.
And also, I'll ask for the 5-number summary. Do you remember the 5-number
Maybe
summary?
show the whole thing again.
Yep, I will. 5-number summary. We're going to make one. Okay? Find your 5-number summary, which is max, min, Q1, Q3, median. There are 7 numbers here, by the way. 7 numbers. I don't know if that helps you or not. But there they are. These are scores on a test that I made up, theoretically.
Theoretically or they're in order. Last test.
Sure. I don't know.
I think they are.
No. I just made these up in my head.
You can tell who got the 99 though.
That was yours? Oh, yeah. Whatever. Obviously.
I always get it on my
I think I got 105, so you're off the list.
Okay.
85 million.
What? Make a box of whisker plot. So, fill this stuff in first, and then make a box of whisker plot from that. If you fill those in first, then I can help you make a box of whisker plot, because I'm very particular about my box of whisker plots. Pretty good.
That was honestly the worst drawing line I've ever drawn.
Man, I don't know. I don't know about this. I don't know about this. I don't know about what Michael's doing over here either.
I did it wrong.
That's a good thing that we're doing it.
Oh wait, it's definitely me.
Yes, it is a good.
I figured it out, don't worry.
I don't know that you did.
85.5
Don't
seems
graph it yet. Don't graph it yet.
Yeah, what is Q3?
85.5 seems pretty right. Let me
That's what
check.
I'll put.
You got some stuff with it, I think.
What you put?
At 85.5.
Oh yeah.
Normally when I list this out, I listed it out wrong. I screwed up. I should have done min at the top and max at the bottom.
Is that right,
Whatever,
though?
it's fine.
I didn't care.
I know.
Wait, dang it,
Usually
now-
I do min at the top and max at the bottom, so I screwed everybody
Let's
up.
go much our maximum in the dots. Maximum in the
Yes.
Is that right though? Did I get it right?
Yeah, I think so.
Am I right?
That would be adding 5, so you'd add 2. No.
Okay, are we ready?
No.
I'm
No.
just finishing.
You don't have to graph
Go
yet.
with you.
I think so, yeah, that should be about right.
I think I might be off at like 1.1 on the line, but it's okay. I'm just that good.
I don't really care if I'm all that off.
John, that's not the way you do good on the test.
Yes, it is.
By not caring. Now that's not a very positive thought.
Yeah, no.
All right, should we fill in your numbers? Quick? No, wait.
It's easy.
'Kay.
It's really easy when there's odd amount of numbers.
Mm-hmm.
You just gotta cross out the middle number. You just gotta cross it like dot, 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 dot.
I'm just guessing what things are.
John.
No pressure. What?
All you gotta do is a little.
Chill out.
John, do
Does it
this.
look right?
Much
Probably
faster.
not.
Looks pretty close. I mean, maybe, depending on what your units are. Okay, max. What's your max number? 99. Mid number? 78. The median. There are 7 numbers.
83.
80. This 83, right?
Yeah.
That 83 is your middle number. Now,
80.
when you have an exact middle number,
You gotta
what do you
cross it
do?
off the list.
you
want
throw it out. If I didn't have an exact middle number and I was taking the average of 2, I would still include them. But I throw that one out, and now I do the
80.
Q1
80,
by the middle of those guys. So 80 is my Q1,
And then 88 is my Q2.
and then 88 is going to be your Q2. So that was the difference. If you got some decimal numbers, you shouldn't have, because you should have some exact
Wait,
stuff.
why is
John,
Q3
I saw those decimals.
Q3 is 88 because we threw out this 83, and we had these 3 numbers to deal with and find the middle of. Yeah?
Yeah, get some more practice.
The average of what?
That makes so
Okay, I will.
For your median or for your Q1 and Q3?
Okay, John, I got a question.
But you should have a middle number. Yeah.
Okay.
Okay, all right, now, be careful when you're doing your actual box and whisker plot. Do a scale first.
Do you know?
What do you want to go by?
I kind of did one.
Okay.
What do you want to go by?
I'm gonna need a humongous cheese grater.
Like what?
Why?
You want to go 75 to 100?
Losing.
75, 80, 85, 90, 95, 100. That's all. Okay, 95, 100. All right. So min, I'm gonna start with 78. Abouts there. 99 abouts there. 80 is there. 83 is there. 88 is there-ish. Okay. All right. Now let's talk about. This is the.
I'm fired. Gucci.
This is right
My
skewed.
Gucci bibs.
No, that doesn't make sense.
I know it doesn't, but check this out. What's my right foot look like? I was drawing feet and they were making fun of me.
Looks like a syringe.
Why are you drawing feet?
There's my foot. There's my foot. What's your foot look like? Like that. The majority of like the values are over there on the left side.
Right
That's
foot.
the left foot.
That's my right foot.
That's left.
That's my right foot. You're being
What's wrong with your
crazy.
foot?
You're crazy. You're crazy. Anyway, all right, now let's talk about the one thing that is making this right skewed. What is making this right skewed?
It's really far to the left.
The 99 is what?
Making it
What's that thing called? We haven't talked about this yet.
big number,
What's it called?
the hypotenuse.
No. Nice try. What's that thing called?
The skew.
No. What's the 99? It's way far away from all the other numbers. What's
The
it called?
outlier.
Oh, it's an outlier, right? So outliers a lot of times will skew your data.
My right foot.
Okay?
We've talked
Will
about
skew your
this.
data. All right, we'll talk. Hold on, we'll talk about. I'll stop the video and then we'll talk about idiot toes. Okay? All right. Goodbye, people in the video.